me introduce our first keynote speaker from Starknet. Please welcome Ms. Gnana Lakshmi, Guest Advocate of Starknet to the stage and deliver her leadership to our participants. Hi Gnana, please turn on your mic and camera. Say hi to everyone.
Awesome. Thank you so much for having me. I'm really excited to be doing the keynote here. I have been in the DevRel space for a while now, and just a heads up, I do talk a lot. So when it's 20 minutes, just let me know, stop, and I'm gonna stop. Right? I have a slide that I generally deliver, which takes about 30 to 40 minutes, but I'm trying to kind of condense it to make it happen. Let me share my screen and we can get started. Okay. Oh, sorry, I'll have to quit and reopen Discord. Okay, I'm back. Can you hear me? All right, perfect. Um, yeah, let me just share my screen. I'm gonna see how screens. Okay, let's see. I'm just gonna share my entire screen and then switch to this. So, is everyone able to see my slides? And the title says Explore the World of Starknet. Yes.
Yes, we can.
Okay, perfect. All right. All right. Thank you so much, everyone, first off, for joining today. I know it's a weekend, and I'm really excited that a lot of you are interested in embarking on this journey to want to learn. Especially now that zero knowledge proofs are, and I was recently reading a lot of posts about this, that zero knowledge proofs are not just going to help scale the blockchain world, but it's also going to be that a type of emerging technology that can potentially change the way we interact over networks, right? We interact every day, we interact over network, right? We use our laptops, we browse on Google, we send messages to each other on WhatsApp or on Telegram, etc. So zero knowledge proofs, this whole mathematical concept and this whole concept of computational integrity can potentially change the way we actually network and we interact with each other, right? And Starknet is one of the components that is built using this idea of zero knowledge proofs. And I will talk a little bit about today. I'm here to talk a little bit about that. Quick introduction about myself. I'm Gnana Lakshmi, and everyone calls me Gyan. That's how you can see my name. I work with the Starknet Foundation as a Starknet developer advocate, and I also have my own community called the Phoenix Guild. I'm one of the co-founders of that, which focuses on education and mentorship in the Web3 space. I've been in Web3 for about 7 years. I'm completely on the technical side of things. I've worked with multiple different types of protocols, you name it, and I've done it. And I've been in the software space for about 11 years now. I'm born and I live in India. I can speak a plethora of different languages, and you can find me on Twitter here. So just a quick, this slide, I want to talk about this because there is generally a lot of confusion about the different names and the different companies that exist. So Starkware is the private entity, is the company that was started by one of the co-founders of Starkware, which is the company that you see here, is actually the author of a paper on Starks, which is Scalable Transparent Arguments of Knowledge. And this is the paper that sort of gave birth to this company, Starkware. StarkX is a private solution, or is a sort of is a scalable solution, but it's more so for individual organizations or enterprises, sort of an enterprise solution that uses Stark proofs to generate proof of computational integrity. The last thing that you see on the slide in the below one, which is Starknet Foundation, was just recently established, which will help people learn about Starknet, develop on Starknet, and in general help the ecosystem grow. And what we are here to focus on today is Starknet. Starknet is the L2 rollup, the layer 2 rollup, permissionless rollup that is built on Stark proofs, right? That technology. Starknet Foundation is where I work, which is a non-profit organization. Starkware is the company. StarkX is the L2 Validium, which is permissioned. And Starknet is the permissionless L2 that you can develop on. So let's talk a little bit about Starknet and explore it today, right? Today we'll look at two things. Why Starknet? But before understanding why Starknet, we need to understand why Cairo, which is the programming language that is used to write smart contracts on Starknet. So why Cairo? Let's think about this as a problem that you're facing, right? Put yourself in the shoes of a scientist, a space scientist, right? And you have a space exploration problem. And you need to send basically, a missile, right? You need to launch a missile. Now, for this particular problem, you have different questions in front of you. That in this mission, how do you save fuel? What is the best launch window? What is the best trajectory? You have to calculate all of this using mathematics, right? So how do you do this? As engineers, you will hire a team of engineers. You will ask them to create some algorithms, right? And they may create an algorithm in a general purpose programming language like Rust or C++, whatever it is, right? Now, if you are familiar with Rust, you may know that this crab symbol represents, the Rust debugger. It's a very cute symbol. But what happens in this process, right? And let's say that you need to run this algorithm. This algorithm is very huge. It is very computationally expensive and it is very computationally intensive, right? In your country, for example, you don't have a supercomputer that can run this algorithm. So what do you need to do? You may need to rent out the computer with a rival country, right? Another country, you may want to rent out their supercomputer to run this algorithm. So in a typical scenario, what happens? You give this piece of code, which is your let's say your algorithm, right? You send this piece of algorithm and you want this supercomputer to execute that, right? Now, what happens? You send this piece of code to the supercomputer to execute and it returns to you a result, right? Every program that you run in a normal programming language, it gives you a result, right? Let's say a simple hello world program. What do you want to do? You want to print hello world. So the result is hello world on screen, right? Now, if this supercomputer gives you a wrong result, then how do you know if whether the supercomputer actually malfunctioned and it didn't work correctly, or because it's a rival country, somebody tried to sabotage your algorithm? Because this is a very mission critical operation, right? A space exploration problem. It is extremely mission critical. So what if somebody tried to sabotage, right? You don't know because you can't judge what happened because you just get a result. Now, if you use a programming language like Cairo, which is a provable programming language, you write your program in Cairo and you send this program to be executed on this supercomputer of the rival country. Now, this supercomputer, when it obviously should have the capability to execute this program, let's say it does, it will not only send you a result, but it also gives you a proof that the algorithm you gave me was executed in the exact order that it is supposed to be executed, right? And it doesn't give you it gives you not only a result but also a proof that how did I get this result, because I executed the algorithm this way that you have given me to execute. Now what happens is you can decide by verification whether this particular algorithm was actually executed correctly or not. So when you have a proof, you can verify using this proof whether something happened the way it was supposed to happen or not. This particular type of operation is called computational integrity. what does computational integrity mean? Computational integrity means that a regular computer is able to keep a supercomputer honest without having to rerun the entire algorithm. So, if this particular execution by the supercomputer is intentionally or unintentionally modified, the generated proof will be invalid because you cannot prove that you followed the exact same steps if you didn't follow the exact same steps. So, what are some of the features of Cairo? And why should you learn Cairo, right? Cairo helps you create provable programs. So, Cairo is not just used for writing smart contracts on Starknet, but it can be also used as a general purpose provable programming language. And going forward, we hope that Cairo can be used for other things just apart from Starknet also. So currently, Cairo is used for writing smart contracts on Starknet, but it's a provable programming language. It runs on top of a Cairo VM. Like I said, you need some sort of VM to actually execute and create a proof for this program, right? So right now, it runs on top of a Cairo VM. Its syntax is very much inspired by Rust. So I also tell my students or tell people who I'm teaching that, hey, if you're learning Rust and you're learning Cairo will be much easier if you're learning Rust, and learning Rust will be much easier if you're learning Cairo. So it's actually like a 1+1 free offer. It has a very similar ownership model to Rust. It is strongly typed and it can also be used outside of Starknet. You don't need to know ZK in order to learn Cairo. So here is just some example code. I'm not going to go deep into this, right? I'm just going to skip through all of this. And why Cairo? Because it helps you create provable programs. It helps you generate a proof of computational integrity. And you can verify whether a particular set of computation ran correctly or not without re-execution and without wasting more time. It's a powerful and flexible language. It prevents cheating and malfunction, and it keeps a supercomputer honest, which is what computational integrity is all about. So, why Starknet? Why should you learn about Starknet, right? I already hopefully made a compelling case to learn about Cairo, but Starknet is the layer 2. So, why should you learn about that? What does it provide? Like, what does it offer? So, if many of you have already been in the Ethereum ecosystem, you know that Ethereum as the layer 1 in itself has a scaling problem. So, what is the scaling problem, right? In Ethereum, when you produce a new block, there is a state change that is happening inside, right? For example, you are changing some sort of variable or you are transferring Ether from one account to another. All of these operations are nothing but state changes, right? That means the value of something changes in the system, and that's what is reflected on chain, right? So, for example, here, let's say that there is a state change and the new state is 42. And how do you check whether the state change is correct or not? There are a lot of validators in the ecosystem that rerun the entire execution. So if you see, this square represents the amount of, say, for example, time that it takes to run the execution. And these validators rerun this entire set of execution, right? To validate whether the state change is correct or not. And then based on the consensus algorithm, the block gets added to the blockchain. Now, if you run the same thing on Starknet, right? On Starknet, which is a layer 2 above Ethereum, you can execute once and verify everywhere. What does that mean? As you saw before, because you're going to write your programs in Cairo, you not only generate a result, which is the state change result, that is the new state is 42, you also generate a proof that this particular state change was produced by doing computation like this. Now, these validators, which were rerunning the entire execution, now don't have to rerun the entire execution. They will just have to take this particular proof and they will have to just verify it. So the time taken to verify this proof is much, much lesser, as you can see, than the time taken to actually run the entire execution. And this is what it means by execute once and verify everywhere. So this offers a scalability to the Ethereum ecosystem. As you can see that the sequencer, which is the L2 element, which is doing the actual computation and also producing the proof, takes much more time than the validator, which is just performing the verification. And this verification is even more improved now with proof recursion, right? So Starks you also use recursive proof generation. So there are other algorithms as well that are there which are using recursive proofs. So the timing is much improved. So you can see in the chart, right, that the actual time taken to verify is much lesser than the time taken to execute or rerun the entire thing all over again. So you think of validity proofs as when you see a file and when you want to transfer the file, right? And if you want to make the file easily accessible, then you will compress the file into a zip file and transfer it, right? So similar to that, here what we do is the computation in a roll-up scenario. The computation is compressed and a proof is created that this computation was run the way it was supposed to run. And this particular proof is called validity proof, right? Why are these rollups called as ZK proof based rollups? That's because they use the algorithms that are underlying in the ZK ecosystem. For example, Starknet uses an algorithm called Starks, Starks. The other popular algorithm that you will hear is SNARKs, right, which is succinct non-interactive arguments of knowledge. So uh, these these proof systems use the underlying mathematics behind these concepts, and that's why sometimes they're also called ZK proof based rollups, but they're actually not completely ZK. Why? Because every ZK based application actually has to adhere to three properties. The third property is called zero knowledge. That means you should you should be able to have some private inputs. However, most of the permissionless public layer 2s, which uses the ZK concepts, are actually public, right? So you can't really have private privacy over there. And that's why the proof system is called validity proofs. They validate whether a particular computation is correct or not by generating a proof from that. So validity proofs are actually a use case of zero knowledge proofs. They are used for compression and not privacy. So that's why Starknet is focused on scalability. You can build privacy preserving applications on top of Starknet as a layer 3 by building your own app chains. But the aim of Starknet is to give scalability to Ethereum. So basically, if you have a question, what can I build on Starknet? You can build anything. You can build any project that you decide to build on any layer 1, because layer 1 is congested right now, and layer 2s like Starknet and other ZK based layers gives you the ability to compute fast as well as compute cheap. So Starknet is largely used for compression. If the and the output that you get is a result of program plus inputs. Output can be verified without the inputs. So that's the way how your most of your zero knowledge proof algorithm works. And the validity proof is why it is called a validity rollup. And Starknet is based on Starks, not Snarks. It's an efficient proving and verification mechanism. I'm going to quickly talk about Starks versus Snarks. It's already quite common knowledge. But Starks, the verification time of Starks. So I want to go a little bit behind and say that when you compare Starks and Snarks, the verification time and proof size of Starks is much higher than Snarks, right? This is not a good thing, and we are constantly working on improvising on this. But why should you still opt for Starks or Starknet? It's because of some other factors that make a lot of difference in long time applications, right? Your proving time is much lesser. You don't need a trusted setup. That means it is decentralized from get go. for snark based algorithms, you need to have a trusted setup, you need to have a trusted setup ceremony. There are some advancements happening there as well, but I don't want to go into that. But you don't need a trusted setup in Starks, so you can be decentralized right from get go. And it is quantum secure because it is dependent on something called as collision resistant hashes. So that's why when you're thinking of building long term products, which is what I'm hoping that you're all building, right? As entrepreneurs, as product creators in the Web3 space, we are looking at building products that will be used down the line 10 years, 15 years, or for the longest time, right? So when you're thinking of building long term, you want to make sure that there is enough security, there is enough decentralization in the kind of products that you're building. This is a question that we get often a lot, that what is the difference between Cairo VM and ZK EVM, right? One of the main things that I want to say is that Cairo VM focuses on performance, whereas most of the ZK EVMs or all of the ZK EVMs focus on compatibility, right? That's why they are ZK EVMs. Because EVM is extremely popular, they have coded EVM into the ZK circuits, right? And that's how ZK EVMs work, whereas Cairo VM is its own category of virtual machine in the zero knowledge space. So I want to quickly talk about this because it's a very common question that we get. I want to refer to Vitalik's ZK EVM classification. You can also find this paper, this blog on Vitalik's blog site. But he shares a very interesting classification that is different types of EVMs. It type 1, you don't change anything in the EVM. It's full compatibility. However, the performance like proof generation, verification, everything will be very, very slow. In type 2 ZK EVMs, which many of the EVMs are trying to aim to be type 2, like Scroll, Tyco, etc., are trying to be like, they want to be type 2. So in this type 2 EVMs, you only change the storage data structure. It's a very high compatibility with EVM, but the performance is still going to be very slow. Because EVM is not built for creating proofs. EVM is your normal VM, which is for, Ethereum. And then type 3 ZK EVMs, which you will find almost everyone today, right? Kakarot, which is a project, ZK EVM project built on Starknet, ZK Sync, Scroll, Polygon, ZK EVM. Many of these are type 3 or type 2.5, somewhere between, wherein you make some small changes to EVM, there's partial compatibility, and the performance is fairly fast. However, if you have a completely different VM, which is like Starknet, Cairo VM, or Polygon Maiden, the performance will be very, very fast because it's specifically designed, the CPU architecture is designed for optimizing proof generation. And that's why it's important to know what the difference is when you are, going into certain ecosystems and trying to build over there, right? So this is basically the categorization. And Cairo VM focuses on performance. That's why we have a type 4 VM, which is a completely different VM than EVM. And that's the focus because we want long-term products to be built on Starknet, right? So you can see here there is some like numbers for you in terms of what is the L1 finality, like how much time does it take for the block to get accepted on L1. So there is a pathway, or there is a structure for a block to get accepted on L1. First, it gets accepted on L2, and then a proof is generated, and then it gets accepted on L1 once it is verified, right? So here is just some performance numbers. And yeah, why Starknet? I just want to close with that. It's optimized for ZK tech. You get higher computing power with lower gas fees. It's secured by Starks and layer 1 security, which is very, very important for all the layer 2s. That is Ethereum security itself. You have a powerful programming language, that is Cairo. There is already a battle tested tech stack, which is our Stark X. It's been running for the past 2 years and has done over $1 trillion of transactions. And you take a fairly lesser time as compared to other ZKVMs right now to withdraw the assets to L1, and there is no trusted set. All right. That was just about,
Thank
I
you,
think.
Anna, for the beautiful
Okay.
slide and a nice presentation. I believe that our audience have had a deeper understanding about you and also about Starknet. And thanks for being here.
Of course. Yeah. Thank you so much for having me. And if you have any questions, feel free to drop me a message on Twitter. I'm at, I'll just put, I think, in the general chat, I'll put my Twitter handle as well. And or Telegram, wherever. And if you're interested in learning anything on Starknet, I'm happy to share resources. We are going to be hosting a bunch of events in during Dev Connect Istanbul as well. And then after that in India, during ETH India. So if you're around, then definitely would love to invite you. Come down, speak to us, and happy to help in any way possible.